So this is the model I use is a very basic new Keynesian model. Those who have done economics in the graduate work or taught them in the past 15 years will of 20 years, 25 years recognize that this is a very familiar story. So there's monopolistic competition and adjustment costs. There are consumers who do these things that I mentioned and buy goods and supply labor, and they own the firms that produce goods. And consumers also hold money and bonds. Price setting by the firms is subject to cost, so there's a gradual adjustment of prices, some stickiness of prices. And then there's a government. This is a simple model, so they buy some goods and services and use it to partly finance it by the taxes and partly by issuing bonds. And then here's the final equation, which is this is the monetary policy rule. And now I've now been a bit more precise here, said that this policy rule depends on expectations about the future. That's what this T+1 there means for the time being. And if you do that and then start solving this model in terms of just keeping the expectations as exogenous constants, not necessarily constant, but possibly varying over time, you can boil this system down into two key equations. One is indeed the Phillips curve. And I'm now going to allow for nonlinear Phillips curves. This is not a linearization near the target, as much of the literature has done. So here's the Phillips curve, what you get. You get a nonlinearity, first of all. There's a variable q, which is actually a quadratic function of pi. But if we keep pi below 1/2, which means a 50% deflation, which would be very much, then q depends uniform, is an increasing function of pi. So this is just says here we have a function of pi which is increasing, and it depends on these variables. It depends on gross outputs yt, also expected future values of gross output, and then also a ratio of gross output to output minus government purchases, and also expected government purchases. And since I'm for the time being keeping government purchases constant, I'll just put a G bar there. So that's one part of the story equation. The other equation is an aggregate demand curve. And here I make a simplifying assumption, which has been done in much of the literature, but one could do it without it. I assume that consumers are, in a sense, Ricardian. Those who are economists know about Ricardian equivalence. This is outside the usual equilibrium story, so I'm speaking about consumers being Ricardian, which says that they know they are smart enough to think in terms of that there's a government also which is taxing us and buying some of the goods in the market, and that has a budget constraint. And these consumers have their own budget constraint and the government's budget constraint. They put them together, and for the future they use the prices that they expect. Future prices or inflation rates are what the consumers themselves expect. But they expect that this is the government, they are integrated together. And so if you also have an optimality condition, an Euler equation, you do everything. What you end up with a consumption function, which says that consumption by consumers in period t is a small fraction, 1 minus beta. Beta, remember, is the time preference parameter. Small fraction of this term in brackets, which is this is the net income in the current period of the consumer. And then this is the present value of net future incomes of the consumer. Where the Ricardian assumption comes in is the fact that these net incomes are gross output minus government purchases, not taxes. The basic formulation would have taxes in it. And then quite naturally you would have a consumption function. This is the sort of life cycle consumption function and so forth, which comes under certain assumptions, where you say that it depends on the present value of net incomes. But with the Ricardian assumption, the net is defined in terms of government spending, not the taxes that it imposes. So that's the second part of the assumptions that I will